Hello everyone, myself Sai Prasad, Alexa in Ahmedabad High School and the Junior College. Welcome to the series of the lectures of Intermediate Second Year Maths B. We started a discussion with the chapter Integration. What did we learn? We started with the basics of how do we find the integration of a function. Then we learned how do we find this UV product, that is integration by parts. Yes. Then we used different techniques, whether it is substitution method, partial fraction method, and various methods we have seen in order to find the integration of a given question. Okay, fine. Whatever the integration we did, that is only once or twice integration, right? If there is a case of multiple integration such as infinite integration like e power x sin x, right? For such equations we use the formula. Fine. With the continuation of that, let us learn the integration of a n times integration, that is infinite loop of integration. Okay. How do we do that and everything? That is simply by a reduction technique. How do we use that reduction technique? Shall we do? See here. The question, the popular and the first main question is integral of sin power nx dx. Okay. This is, if it is sin power 1, we have to integrate only once. If it is sin square, we have to integrate 2 times. If it is sin cube, then it is I3 like that. Is it okay? That is how we have to generalize the solution. Okay, shall we start? See here. The question is given as integral sin power nx dx, but in the solution you also have n power 1, power n minus 1. So, any idea how do we solve this? The only thing, if we have only single term like this, we know that we have to use integration by parts formula. Yes. So, let us use the same integration by parts here. But if you look into here, even if I take this term into 1, we are not going to get much change. So, let us do one easiest thing. After looking into this output, that is power n minus 1, let us write it as sin power n minus 1 x into sin x dx. Right? If I multiply these both, will I get sin power n? Yes, minus 1 plus 1 will get cancelled. Now, can I use highlight? Yes, we will take this as I and this as normal thing, that is we will take this as u. Why? Because there is power minus 1 in that. So, we can generalize among these both, we can take this as u and this as v. Clear? Now, what is the formula of integration by parts? U integral v dx minus integral differentiation of u into integral of v dx whole dx. Isn't it? Is it not the formula? U integral v dx minus integral du by dx into integral v dx whole dx. Okay. So, sin inverse x into integral sin x is minus cos x, integral differentiation of sin inverse x 1 by under root 1 minus x square. Isn't it? Yes or no? This is n minus 1, right? Sorry. So, differentiation of sin power n minus 1 is nothing but n minus 1. Here it is sin power n minus 2x into sin ka differentiation is cos x. Is it right? No more difficulties here. Just check here. This is sin power n minus 1 x. So, x power n form, that is n into x power n minus 1. Yes. Into, instead of x we have sin x. Sin x ka differentiation is again cos x. Okay. Next, integral sin x is minus cos x whole dx. Right? Shall we simplify now? So, we will get it as minus sin power, sorry, this is n minus 1, do not get confused, x into cos x minus, minus to minus, let us write it as plus, let us take n minus 1 common. Clear? So, we will get integral sin power n minus 2x into cos square x dx. Is it right? Now let us simplify in such a way that we will write cos square as 1 minus sin square. So what do I get? Minus sin n minus 1 x cos x plus n minus 1 into sin power n minus 2x into cos x can be written as 1 minus sin square x dx. Now let us multiply with this. Then we will get it as minus sin n minus 1 x into cos x plus n minus 1. If I multiply this, I will get it as sin power n minus 2x minus n minus 1 into sin power n minus 2 plus square. Minus 2 plus 2 will get cancelled. I will get it as sin power nx dx. Is it right? Once again, see here. Here I have multiplied this n minus 1 integral sine into 1 plus again this whole term into sin square. Right? N minus 1 will be taken as common. N minus 2 plus 2, that will be n. Is it right? Fine. Now check here. Minus sin a power n minus 1x cos x plus, what is this? If sin power nx dx integral is in, then sin power n minus 2x dx integral is, instead of n we will write it as n minus 2. So this will be n minus 1 into in minus 2. Right? And the next minus n minus 1 into, what is this term? This is nothing but in. Okay, and this whole term is nothing but in. Yes, so we will take this in term to that side and will simplify to find the value of in. So what do I get? If I take in common here, 1 here plus n minus 1 into in is equal to minus sin power n minus 1 x cos x plus n minus 1 in minus 2. If you observe, minus 1 plus 1 will get cancelled, right? I have taken this here, right? So I will be left with n. If I send n this side, what do I get? In is equal to minus sin power n minus 1 x cos x whole divided by n plus n minus 1 by n in minus 2. This is what they asked us to prove. Yes. So this is what in is. So he is asking us to deduce this formula, that is integral sin power 4x dx. How do we do? That is, instead of n we have 4 here. So let us directly substitute 4 in this and find the value. So put n is equal to 4. So I4 is minus sin power 4 minus 1x cos x by 4 plus 4 minus 1 by 4 I 4 minus 2, which is nothing but I2. Yes. So we have to find I2 now. I4 is equal to minus sin cube x cos x by 4 plus 3 by 4 into, what is I2? Again substitute in the same thing. So we will get it as minus sin 2 minus 1 is 1 cos x by 2 plus 2 minus 1 is 1 by 2 I0. I0 is nothing but simple sin power 0, which is 1. So we need not write it. Is it clear? So let me tell you once again. Here he is just asking us to reduce the formula of integral sin power nx dx. Why? Because we can't do it as an infinite loop. We will just reduce the formula as this. How do we do? First main logic is sin power n minus 1 into x into sin x we will write. How? Instead of n we will write as n minus 1 into 1. Okay. Then we will use the uv formula and reduce, so that we will get all in's to one side. Yes. Similarly, we will have the formula of sin power 4x, that is the direct solution, just while substituting in the reduced formula. Clear? Is it okay? With the same knowledge, let us learn how do we find integration of a cos power n x. Okay? Now we have to find the reduction formula of cos power n x dx. How do we find? the same logic, let us write cos power n minus 1 into cos. That is, let us write In is equal to integral cos power n minus 1x into cos x dx. So, let us take it as u and let us take it as v. So, what is the formula for integral uv? That is u integral v dx minus integral differentiation of u into integral v dx whole dx. Is it fine? So, let me write cos power n minus 1x, integral cos x is minus sin x, sorry, only sin x, right. Next, differentiation of cos power n minus 1, that is n minus 1 into cos power n minus 2x into cos x ka differentiation is minus sin x. Yes. Now, integral cos x is also sin x whole dx, right. Now, see here, this is cos power n minus 1x into sin x minus into minus plus n minus 1 into integral cos power n minus 2x into sin square x dx. Is it clear? So, what is the next step we are going to do? We will just convert the sin square as 1 minus cos square. What did we do in that sum? We converted cos square into 1 minus sin square and we simplified. Clear? The same story it happens here also. So, this will be cos power n minus 1 into sin x plus n minus 1 into integral cos power n minus 2x into 1 minus cos square x dx. Clear? Now, let us multiply everything. So, what do we get? Cos power n minus 1 x into sin x plus n minus 1 into integral cos power n minus 2x dx minus integral, sorry, let me write n minus 1 first, into integral cos power n minus 2 into cos, that is cos power nx dx. Clear? What is the next step now? Here, instead of n we have n minus 2. So, we can write it as I n minus 2 and here it is directly I n. So, we will write it as I n is equal to cos power n minus 1 x into sin x plus n minus 1 into this is I n minus 2 minus n minus 1 into this is I n. Clear? Now, let us write this term onto the left hand side. So, we will get it as I n into 1 plus n minus 1 is equal to cos power n minus 1 into x into sin x plus n minus 1 into I n minus 2. Is it right? So, here 1 minus 1 will get cancelled. We will write this n into denominator for this term. So, I will get it as I n is equal to cos power n minus 1 x into sin x by n plus n minus 1 by n I n minus 2. This is the required solution. Clear? No more difficulties here. Fine. So, let us deduce this value, that is we have to put n is equal to 5. So, I will get it as I 5 is equal to, let me write directly, 5 minus 1 is 4x sin x by 4 plus 3 by 4 I 3, isn't it? Since it is 5, 5 minus 1 is 4, sorry, here it is 5 and here also it is 5. I 5 minus 2 is 3. Now, we have to find the value of I 3. So, this is cos power 4x sin x by 5 plus 4 by 5 into what is I 3? Again the same story, cos 3 minus 1 is 2x sin x by 3 plus I 3, 3 minus 2 is 3 minus 1 is 2 by 3 I 1. Is it clear? No more difficulties still here, right? So, let us find this I1 now. What is it? Cos power 4x sin x by 5 plus 4 by 5 into cos square x sin x by 3 plus 2 by 3. First integral, that is integral cos x. Integral cos x dx. Right? So let me write all the answers now. 1 by 5 cos power 4x sin x plus 4 by 15 cos square x sin x plus 4 2s are 8 by 5 3s are 15. Cos x ka integration is sin x plus c. Is that right? Don't get confused. Systematically you have to do. This is cos power n minus 1 into cos. This is u and this is b. U integral v dx minus integral du by dx into integral v dx whole dx. We'll substitute. Remember only these few things. First doing like this. The next after integration you have to write the sin square as 1 minus cos square. Then after writing them as in minus 2 and in. Bringing to that side, dividing the term onto the right hand side. Clear? Did you understand? These are the basic reduction formula. That is what all we learned today. We started with the sine parent, then we did cos parent, and then we deduced a few things. That is for sine we deduced one thing, and for cos also we deduced one more thing. Clear? Fine. Similarly, we will have cosecant parent, secant parent, tan parent, cot parent also. Is it clear? Is it okay for now? Good. This is for today. Let us meet in the next session with the more reduction formulas. Thank you.